Alright, this is Lab 1 charge tapes. The purpose of this lab was to approximate the excess charge on a piece of charged Scotch tape. To do so, I set up this model and found the distance that it took for the tapes to repel each other. Some important information is Coulomb's law, your gravitational force equation, you gotta know like charges repel, and the charge of an electron. In the end, the result was the charge was approximately 1.63 times 10 to the negative 9 coulombs. To figure that out, we have to figure out first what the charge of the tape was. I set up this model, ripped off the tape very quickly, which charges that top piece of tape. I was expecting that if I brought two pieces of charged tape together, that they would repel each other, and that did in fact happen because they are the same charge. I also brought that piece of tape up to a neutral object, and it attracted. If the tape was positive, and since a plastic pen will always be negatively charged, they should attract. And the opposite goes for if the tape is negative, because both negative repel. And a neutral piece of tape should be attracted to the pen, because any charged object is attracted to neutral objects. And the pen was attracted to the tape, and we know that the tape is charged, so the tape is positive. With that information in hand, we have to set up our model here with all of our forces. Gravity is acting down, and the electric force is acting up on the tape. The net forces should be zero, so these should be equal to each other. To find the gravitational force, though, we need to know the mass, and with a handy-dandy conversion that the lab gave us, all we need to know is the length. We don't actually have to weigh it out. Our assumption is that the two tapes have the exact same charge, which is not probably right, but we have to assume it so it makes our equation a lot cleaner. And another thing to make our equation a lot more simple is that the two tapes are just 1 point charge and not taking the whole entire piece of tape into account. Our initial values were the length of the tape and the separation between them. The two tapes wouldn't start to repel. And we need to find the mass of the tape now to find the gravitational force. Well, we know the length. To do a little bit of conversion, we found out that it's 0.0002 kilograms. Kilograms because that is the unit we use in physics. The gravitational force, since we know mass and we know the acceleration on Earth, 9.8, found the force. Force has to be equal to the electrical force, so plugged into this equation with the distance being the separation, and solved that Q is equal to 1.63 times 10 to the negative 9 coulombs. The deficit of electrons, it's deficit because it is a positive charge, not negative. Found out that there's a deficit of 1.021 times 10 to the 10 electrons. Now, to figure out the amount of atoms on a piece of tape, just use a little bit of conversions here. Found that it's that many atoms in one piece of tape, in the piece of tape that I had. And then there's a ratio of 1 electron to every 4.2 times 10 to the 6 atoms. Our one assumption there was that the tape is 1 atom thick, which most likely is not right, but we have to make some assumptions. Now, our code, first did a few definitions here just to find some basic, K is equal to 9 to the 9. Made the objects, made the force of gravity equal to the mass of the tape times negative 9.8, and then the charge has to equal the, this is just putting our force of gravity equal to the electric force. And then it defined the electric force equation and defined the gravitational force equation and came up with this model. Now, some errors in this. Whenever we touch the tape, we are dispersing some of those electrons, which means the charge is going to disperse a little bit, so it's not going to be exact. The measure of the distance between the two tapes wasn't exact. We were using just a normal ruler, and it doesn't go down to, it only goes down to like the 0.0 centimeters, so millimeters. Also, the weigh's an estimate. We didn't actually weigh it. We just used a conversion, and all the forces from the surroundings were not accounted for, like any airflow around and stuff like that.